What is permittivity? The definition follows: ability to store electric energy in an electric field. The physical meaning of this particular definition is, out here we have two charges, Q1 and Q2. Now the force of attraction or the repulsion is taking place through some kind of interaction between these two charges. This charge and this charge, there is some kind of interaction taking place in between these two charges, such that they either repel each other or attract each other. And out here in this particular case, it is the vacuum, that is the medium between these two charges. Okay, and hence epsilon naught is the permittivity of the free space or vacuum between these two charges. That is, how much energy can this particular vacuum or this particular medium between these two charges can hold. That is, suppose if the energy being transferred from Q1 to Q2 is about 100% of energy is being transferred from Q1 to Q2. Okay, and when it reaches from this point to this point, only about 70% of the energy is reaching Q2, whereas the 30% of the energy is lost. So this 30% energy is the ability of this particular medium to store the energy in an electric field. It is the strength of this particular medium to hold this much amount of energy in itself. So this is the physical significance of permittivity of a medium, where how much energy can it hold in itself in case of electric field. And suppose now this is an example for permittivity of free space. Now suppose if I introduce some kind of medium out here in between them, consider water, just an example. Now I have introduced a medium. Okay, so absolute permittivity of the medium means, absolute permittivity is when you place a medium in between these two charges, interaction is going to take place. But now what is the amount of energy this medium is going to hold? That is the absolute permittivity of the medium. And this epsilon divided by epsilon naught gives you epsilon r, where epsilon r is the relative permittivity of the medium. Relative permittivity of the medium. This epsilon r is also known as the dielectric constant. This epsilon r is also related to the capacitance, which you are going to understand as we go on with the lecture.